scroll back up to it, it just changed. Okay, so we're starting off with this guy here. You look bored.
Hmm?
I said you look bored.
No, I'm not bored, actually.
No, I mean like just in general. Like you seem like somebody like sucked out your energy.
Okay.
Alright, so we're doing an E2 reaction. Right, because they told us. Did they tell us? No, they didn't tell us. Okay, well, this is gonna be an E2 because we have a strong base. And this is a tertiary substrate.
So in order to like find out which one you have an E2 and an Sn2, do you just have to like know your bases?
Yeah, something like that. It's part of it. So strong bases by default go by E2, Sn2. And then this tertiary substrate gives it off even more. So what's going to happen here is we're going to get an E2. In an E2 reaction, we look at the beta hydrogens. Those are the hydrogens that are getting deprotonated. So this is the alpha hydrogen. This is beta carbon. So this is the alpha carbon, beta carbons.
Yeah.
It's also a beta carbon. Now we want the hydrogens on the beta carbon. This beta carbon here does not have any hydrogens on there, so we don't look at it. Right? So the beta carbon is the carbon adjacent to the carbon that has the leaving group on there.
Okay.
Right. That carbon is the alpha carbon. Now when we have a base that's unhindered,
What does that mean?
it means that it's not like sterically hindered. This is sterically hindered because it has a lot of other groups.
Oh, okay.
So when we have a base that's not sterically hindered, it's going to form the more substituted double bond. Notice that in one scenario we can take this deprotonated and kick this off, and we would form this. Right?
Okay.
Or in another scenario, we can deprotonate from here, double bond, and kick this guy out. Then we would form right.
Oh, I see it. Okay.
So now, when you use a small base like this, so a sterically unhindered base, you're going to form what's known as the Zaitsev product, which just means that
substituted carbon.
okay, more
With double bond attached to the more substituted carbon. We went over that.
more substituted double bond.
Yeah, sorry.
It's okay. Cool. So which one of these do you think is more substituted? The one on the top or the one on the bottom?
On the bottom.
Okay, so you think this one is more substituted. Why do you think this one is more
Because
substituted?
this carbon is more substituted. Oh wait. You're right. Hold on. Yeah, because of this carbon is more substituted than. Wait, no. Oh, because these two carbons are more substituted than. Like, I don't know how to explain it, but
It's
if you
okay.
place it here, you're putting it between two highly substituted carbons. If you place it here, it's only one highly substituted.
Okay, so the way you want to look at it is you want to look on each carbon of the double bond.
Yeah.
This carbon here, this carbon here, this carbon, this carbon here.
Mm-hmm.
This carbon here has no carbons coming off of it,
Okay.
whereas this one has two.
Alright.
This one has two, and this one has one.
Okay.
This is more substituted. This has 1, 2, 3 groups, whereas this has 1, 2. This is more substituted. Major product. Right, and so here we have wage. And we're reacting this with HBr and heat. Right. We need to show the product.
What's your leaving group?
Hmm?
What's your HP the leaving group?
Yep. So this is a different scenario.
By VR? Wouldn't it be that way?
Yes, that's right. It will be replaced by VR. This is a different example. Okay. All right. So this is my leaving group.
Yeah.
But this
Isn't usually VR leaving group and then OH is what
yeah, I see what you're saying.
replaces. You know what I'm saying?
Yep. So this is going to be a bad leaving group. So we got to protonate it. Protonated, it becomes a good leaving group. Right? So this, the lone pair is here. It's going to grab out and take this hydrogen. Bond is going to break. We're going to form.
VR is going to attach.
First of all, we're going to protonate it.
Oh, I don't want to protonate it. The bond protonates it.
Alright, so this bond is going to break. And we're going to form a carbocation, like always.
And then the bromine is going to attach there.
Perfect.
Easy peasy. Like that?
Yep.
No.
Wait, you might have added too many carbons, but
Never mind.
1, 2, 3, actually. Oh, okay. Oh, sorry. It's on the, attach it here. This is a minor product.
Oh, it's the most substitute.
We forgot about the rearrangements. Remember that carbocations can rearrange?
Yeah.
So there would be some rearrangements occurring.
It's almost time for the final.
Are you serious?
I have two finals.
Here.
I have the Orgo final and genetics final.
Wow. Well, it's about a month away, so that's still a pretty long time.
I have to listen to music.
What are you doing during Thanksgiving?
I'm gonna be here.